Hello, today we are going to be talking about factoring binomials using the dots method. So our instructions are to factor each expression. So DOT stands for difference of two squares. These are actually perfect squares. Okay, so this is a shortcut method that I can only use if I have a difference, which I have in the first example, two terms, which I have, x squared and 25, and they are both perfect squares. Perfect squares means that you have two identical factors that multiply to get your product. So x squared is a perfect square because its two factors are x times x. 25 is a perfect square because its two factors are 5 times 5. So since we satisfy all of the requirements for the difference of two perfect squares, we can set up two sets of parentheses. One gets a plus, one gets a minus, and then I take one of each of these factors and place them in the parentheses. So x came first, so x in the front for each, and then 5 in the back for each, and we are factored. Okay, so let's take a look at example number 2 and 3. So for number 2, x squared minus 100, it is a difference, it has two terms, and they are both perfect squares. X squared is x times x. 100 is 10 times 10. Be very careful. A lot of students identify this as 50 times 50, but 50 and 50 add to 100, not multiply to 100. So since this is a difference of two squares, I can set up the parentheses 1 plus 1 minus. Each factor goes into the parentheses in the front for x squared, and each factor of 100 goes into the back half of the parentheses. And you are finished. So just want to let you know it doesn't always have to be plus and then minus. You can use the commutative property and write this as x minus 10 times x plus 10. Either one is completely fine. I usually write plus and then minus first. If we take a look at example number 3, you'll notice I have a difference of two terms. Both are perfect squares. Even though I have a coefficient of 4 here, it is still considered a perfect square because two numbers that multiply to make 4 are 2 and 2, and the two variables that multiply to make x squared are x and x. So the two factors are actually 2x times 2x. And then the two factors that multiply to make 9 are 3 times 3. So again, difference of two perfect squares. One's a plus, one's a minus. The entire 2x goes in the front of the parentheses now, and 3 goes in the back half. And now we are factored. So let's take a look at example number 4. Okay, for number 4, we have 16 x to the 4th and 25. This is a difference, two terms, both are perfect squares, because two numbers that make 16 are 4 and 4. And what makes x to the 4th is x squared times x squared. And two numbers that multiply to 25 are 5 and 5. Again, identical factors for both. Now I set up my parentheses. One gets a plus, one gets a minus. Our entire term 4x squared goes to the front for both sets of parentheses. And then we place our 5 at the back. For number 5, I have two different variables, but I can still use the difference of two perfect squares because two numbers that are identical that multiply to 36 are 6 and 6. X to the 4th is x squared times x squared. And for 49, 7 times 7. And y to the 4th is y squared times y squared. So you can do this with variables that are not just x. All right, so let's write this out. I have two sets of parentheses. One's a plus, one's a minus. Take our 6x squared, place it in the front. And then we take our 7y squared and place it at the back. And we are factored. I hope you enjoyed. Thanks for watching A Heiser Creation. Bye-bye.